Hello everyone, and welcome to the second half of 8.6, which is solving rational equations, and we are going to be dealing specifically with the word problems. These word problems, at least every single time I took the ACT, at least one of these always showed up. Particularly, I think the most manageable and easiest to kind of figure out of all of them is the work type. But there are three types. There are mixture problems, which always deal with something like chemistry related, something with going against the current or the wind, and then work problems. So for mixture problems, for example, if I had Aaron adds a 80% brine, which is salt and water, solution to 16 ounces of a solution that is 10% brine, how much of the solution should be added to create a solution that is 50% brine? So with these, I think it's definitely best to set up a table to kind of contextualize what we're looking. So originally we had 10% brine and we had 16 ounces. So that's the amount of brine that we had in that solution out of the entire solution, which was 16 ounces. We added 80%, and I don't know how much total I added. So that X is representing the amount of ounces that I've got. So my final solution that I'm looking at is 10% brine, 16 ounces of that, plus the 80% of however much fluid I added over the total fluid, which is the 16 ounces, plus however many ounces I just added. So you set up a proportion. We want 50%, so 50 over 100 equals our new solution amount of brine, simplified, over our total amount of solution, so our total amount of ounces. So with these, since we are already in a one rational equals another rational, you have two choices. You can either cross multiply, which I think is the easiest, or you can multiply the whole thing by the LCM, which will be virtually the same thing. So I'm going to cross multiply. So I've got 50 times 16, which is 800, and then 50 times x, which is 50x, equals 100 times 1.6 is 160, and then 100 times 0.8x is 80x. Now I'm just going to solve for x. So I'm going to move over the 160, move over the 50, so I have 640 equals 30x. At this point I'll divide both sides by 30, and I get 21 and 1/3 ounces. That's how much I need to add to get a solution that is 50% brine. So set up a table, set up your proportion, and then solve for x. Another type is there's always going to be, they're flying and they're going with the wind and against the wind, or maybe they're swimming or sailing and they're going with the current and against the current. So if I have Jennifer swimming for 5 hours in a stream that has a current of 1 mile per hour, and she leaves her dock and swims upstream for 2 miles and then back 2 miles, what is her overall speed? So we set up an equation for ourselves. She went 2 miles, so we went 2 miles one way, 2 miles back, and really which one of these is with the current and against the current isn't the most important thing at all. The important thing is you have the rate that we're talking about that's with the water, that it would be still, so like her actual true rate, minus the rate of the stream or the wind, and then plus on the other one. So that way we are taking into account when she's moving with the current, she's going to be going a little bit faster, and when she's going against the current, she's going to be going a little slower. So I have an equation. I've got my total time on the other end. So at this point, my equation looks like, to kind of condense this a little bit, so I've got an equation. I've got two pieces on one side, so this one is the type that's easier to multiply the whole thing by the LCM, or our least common denominator, which would be, well, here I've got r minus 1 and r plus 1. Here I just have a denominator of 1, so I'm going to multiply the whole thing by r plus 1, r minus 1. So for this first one, I'm missing the r plus 1, so 2 times r plus 1. Plus, here I'm missing the r minus 1, so I've got 2 times r minus 1. Here, since I originally had a denominator of 1, I'm missing this whole thing, and since r plus 1 times r minus 1 is the same thing as r squared minus 1, I've got that 5 times the r squared minus 1. At this point, I do have a squared, so I know I'm going to have to move everything over to one side. So let's move everything to the right. So I just combined all my like terms. I'm looking at that, and I need a product of negative 25 and a sum of negative 4. 99.9% of these won't factor, so we know that we can use our quadratic formula. So opposite of b, plus or minus b squared minus 4 times a times c. 4 times negative 25 is negative 100, so minus negative 100 all over 2a. So I end up with 2 plus or minus square root of 29 over 5 if I simplify. I'm going to plug that into my calculator, and when I do, I get r equals 1.5 or negative 0.7. Since it doesn't make sense to have a negative rate, we know that 1.5 has to be the answer. And since 1.5 wouldn't be an excluded value, we're okay. So for these, you set up your equation, multiply by your common denominator, move everything to one side, use the quadratic formula, and one of your answers will be reasonable. The other one will not be. And these, I think these are definitely the most reasonable of all three of these, and these are, I think, show up more often than the others. The mixture ones show up a lot in like a chemistry type class, but these just show up a lot in general, I think. So if I had Derek and Spencer mowing lawns together, and if Derek worked by himself, he could complete a particular job in 4.5 hours, whereas Spencer could complete the same job in about 3.7 hours. How long would it take to complete a job if they worked together? So we set up an equation kind of like the one that we just did with the wind and current problems. And this is our rate for Derek. So in 1 hour, he'd be able to complete like 1.45ths of the job, and Spencer can complete 3.7ths of the job, and then together I've got 1 over x. So essentially I have 1 over one guy's rate, 1 over the other guy's rate, and then 1 over x, which will tell us our total time in general. So I'm going to combine the left-hand side, and to do that, well, I need to find some sort of answer to what these added together are. So I'm going to take out my calculator. And if I do 1 over 4.5 plus 1 over 3.7 and I hit enter, I get an awkward decimal. But if I hit that math button, put it into a fraction, I have that these two added together is equivalent to 164 333rds. So I'm going to write down 164 over 333 equals 1 over x. At this point I can cross multiply, so I have 164 x equals 333. Divide both sides by 164, and x is equal to about 2.0304, or about 2 hours. If that was like 2.3 or something, then that would be a little bit more significant than 0.0. So together, if these guys were mowing this particular lawn, it would be done in about 2 hours. So these are the type that I think are most manageable, and I think that they show up often enough that it'd just be worth getting comfortable with. So 1 over the rate of one over the rate of the other, 1 over x, and solve for x.